Good morning, children. Welcome back. Yesterday I had asked you to do the sums, that is prep 1, 2, 3, 4. And I had also explained something about question number 5 to find the product of its prime numbers. Okay, writing it in exponential form. Right. I hope you have done at least till number 4. From number 5 we will start today. Question number 5. First one, I had worked it out for you. Now we will do the next one, that is 405. Okay, 405. Sum number 5, part 2. 405, to write it in exponential form. What do we need to do here? We need to find the factors, the prime factors of 405. So we start with the prime factors, that is 405. Check the divisibility of 3, because if it ends in 5, it may be divided by 3. 5 plus 4 is 9. 9 comes in the tables of 3. So this is divisible by 3. 3 ones are 3. 3 threes are 9, 3 fives are 15. Again with 3. 3 fours are 12, 3 fives are 15. 3. 3 ones are 3, 3 fives 15. 3 fives are 15. And 5 ones. So the product of its prime factors will be 3 multiplied by 3 multiplied by 3 multiplied by 3 multiplied by 5. How many times is 3 coming out here? 3 is coming 4 times. So 3 raised to the power of 4 multiplied by 5, because 5 is only 1 times. So 3 raised to the power of 4 multiplied by 5 is the correct answer. Next one, number 3. After this, you need to draw a line from here itself. This should be included in your sum. Okay. Number 3 is 540. Now let us divide 540 by, this is even or odd number. This is an even number. So we will start the division with 2. I don't think there will be enough space, so I will start from slightly higher up. Okay. 540 divided with 2. 2 twos are 4, 2 sevens are 14. Again with 2. 2 ones are 2, 2 3 6, 2 5s 10. 2 6 12, 2 5. Sorry, look at me. This is an odd number. 135 is an odd number. Check the divisibility of 3. 5 plus 3 is 8. 8 plus 1 is 9. So it can be divided with 3. 3 fours are 12. 3 fives are 15. Again with 3. 3 ones, 3 fives. 3 fives. 5 ones. Okay. So now what do we get? Factors, prime factors are 2 multiplied by 2, 3 multiplied by 3 multiplied by 3 multiplied by 5. So how many times is 2 coming? 2 times. 2 raised to the power of 2 multiplied by 3 raised to the power of 3 multiplied by 5. So these will be writing as the product of their prime factors in exponential form. Last one. The fourth one, 3600. 3600. This is an even number. So ending in 0 means it's an even number. So we start with 2. 2 ones are 2, 2 eights are 16. 0, 0. 2 9s are 18, 0, 0. 2, 2 2s are 2 4s are 8, 2 5s are 10, and a 0. Again with 2. 2 2s are 4, 2 2s are 4, 2 5s are 10. 2 2s are 4, 2 2s are 4, remainder 1, 2 5s are 10. Now this is an odd number, so it cannot be divided by 2. So let us try it with 3. 5, 6, 7, 8, 9. 9 comes in the tables of 3. So this is divisible by 3. 3 7s are 21, remainder 1, 5. 3 2s are 6, 5. Now 25, 5 plus 2 is 7. 25 cannot be divided by 3. It will be divided by 5. 5 1s are 5. So the product of its factors, there are 1, 2, 3, 4. 1, 2, 1, 2. So this is written as 2 is coming 1, 2, 3, 4 times. So 2 raised to the power of 4. 3 is coming 2 times and 5 is coming 2 times. So your answer here will be 2 raised to the power of 4 multiplied by 3 raised to the power of 2 multiplied by 5 raised to the power of 2. Now all these sums also, 5 sums, you will be doing it in your classwork book. Next, this will be for your prep. Do it in your classwork book. Next is question number 6. Now all these sums are related to exponential form, where we are going to expand the number and then multiply. First here it is given simplify. Simplify means to find the answer. Not in exponential form but as a product. Okay. First one I will do 2 multiplied by 10 raised to the power of 3. This means it is 2 multiplied by 1, 2, 3. 10 raised to the power of 3 is 10 multiplied by 10 multiplied by 10. 10 multiplied by 10 is 100 multiplied by 10 is 1000. Now in 1000, how many zeros are there? 1, 2, 3. What was the power of 10? Power of 10 was 3. So whatever the power of 10, that many zeros will be there in your answer. Okay, that is how I wrote 1000 here. Power of 10, you have 3 here. That means here you are going to have 3 zeros. So the number of whatever the power of 10 is, that many numbers of 0 you will have in your answer. So 2 multiplied by 1000 is 2000. Second one. I'll do one more, then I shall leave it for you to do it. 7 raised to the power of 2 multiplied by 2 raised to the power of 2. Now 7 raised to the power of 2 means 7 multiplied by 7, 2 multiplied by 2. 7 sevens are 49. 2 multiplied by 2 is 4. Now multiply 49 with 4. 9 fours are 36, carry 3. 4 fours are 16 plus 3 is 19. So answer here is 196. You are finding the product. Expand according to the exponential form. Multiply whatever is in groups. You can multiply. You cannot multiply straight away. So multiply in groups. When you multiply in groups, then finally get the answer. The rest of the sums, you will do it for your homework. You can do it in your classwork book itself. We will check very quickly the answers tomorrow. Next one, number 7. Number 7 is also simplify, which means that you are going to find the answer to it. Now let us recall that if a negative number is raised to an odd power, the answer we will get will be a negative answer. A negative number raised to an odd power will give you negative answer. A negative number raised to an even power, even positive power, okay? Even power, here also odd positive power, even positive power. If a negative number is raised to an even power, then the answer will be positive. Answer here will be positive. Now, related to this concept, you are going to solve sum number 7. The first one is -4 raised to the power of 3. Now tell me, is 3 this number power? This is a negative base. A negative base raised to an odd power. If it is raised to an odd power, answer will be negative. Now we can write the answer in this form. -4 multiplied by -4 multiplied by -4. Now, since there are 1, 2, 3 negative numbers, your answer is going to be negative. Now do the multiplication. 4, 4, 16. 16 fours are 64. So your answer is 64 here. Okay. Similarly, I shall do the next one. That is sum number. Okay, let me do number 4. -2 raised to the power of 3 multiplied by -10 raised to the power of 3. Okay. Now first we are going to solve this. Raised to the power of 3 means I'm going to get a minus answer. 2 multiplied by 2 multiplied by 2. Because we know that we are going to get a minus answer, no need to write the minus sign in the others. Multiplied by, this is also raised to the power of 3. If it is raised to the power of 3, how many zeros will I write? I will be writing 3 zeros. And since it is 3 is an odd number, your answer will be -1000. Okay, let's multiply this. We get -8 multiplied by -1000. How many negative numbers now out here? 2. And 2 is an even number. So what do we get out here? 8000 as the answer. Okay. In the same way, you will work out all the sums of question number 7 in your classwork book. We will check the answers tomorrow. Remember, we are doing today all the sums of exercise 13.1 in your classwork book. Yesterday, you must have done till 4. Today, you are going to do 5, 6, 7 and 8 also. Okay, in your classwork notebooks. Let's go on to, and please do all the sums. I've shown you the example. Exactly the same way you will do the other sums also. Right. Compare the following numbers. Now comparison. Okay. I'll just explain it to you. You should know. 2 multiplied by 7, 2.7 multiplied by 10 raised to the power of 12, or 1.5 multiplied by 10 raised to the power of 8. First thing we need to see here is the power of 10. Because the power of 10 will give you the number of zeros. So among these two, which one will have more zeros? 10 raised to the power of 12 or 10 raised to the power of 8. This will have how many zeros? 12 zeros. Why 12 zeros? Power is 12. So if it has 12 zeros, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 zeros. Okay. This one will have how many zeros? 8 zeros, because the power is 8. So we write out here 1, 2, 3, 4, 5, 6, 7, 8. Which number is a greater number? This is a greater number. Power of 10 is greater than the power of 10 here. So 2.7 multiplied by 10 raised to the power of 12 is greater. You'll write it as greater, and the reason that you will give is the power of 10 here is greater than the power of 10 in this one. Okay, so I'll give you how to write. Since the power of 10 in 2.7 multiplied by 10 raised to the power of 12 is greater than that in 1.5 multiplied by 10 raised to the power of 8. Therefore, 2.7 multiplied by 10 raised to the power of 12 is greater. This is how we are going to write the answer. Okay, I hope you have understood this. The second one is also of the same type. You have 4 multiplied by 10 raised to the power of 14 and 3 multiplied by 10 raised to the power of 17. So which of the two will be a greater number? Which of the two? 17 or 14? Obviously, 17 is greater than 14. So 3 multiplied by 10 raised to the power of 17 is greater than 4 multiplied by 10 raised to the power of 14. So all these sums, you are going to do it in your classwork book. So that is the end of exercise 13.1. Okay. Now we are going to start on with the laws of exponents. So let's get started. Laws of exponents means the basic way in which we do the multiplication of numbers or that of exponential numbers. Okay, I'll give you an example. Supposing I am multiplying 2 raised to the power of 3 with 2 raised to the power of 4. If I have to multiply this, what will I do? I'm going to expand it. Okay, let's not look into the answer. Let's see the process, how we are going to do it. So I'll expand it. 2 raised to the power of 3 is 2 multiplied by 2 multiplied by 2. And 2 raised to the power of 4 will be 2 multiplied by 2 multiplied by 2 multiplied by 2. Now what do we see out here? What do we see? We see that the number being multiplied is the same number here. All the numbers are the same numbers that are being multiplied. So if the numbers are same, that means I'm multiplying 2. How many 2's are there altogether? We are going to check that. 1, 2, 3, 4, 5, 6, 7. So it is 2 raised to the power of 7. Now what did we see out here? Now you check out here. What was the base being multiplied? The base being multiplied was 2 in both the cases. And what answer did I get in exponential form? I got that same base. Has the base changed here? No, base has not changed. Base is the same, okay? Because same bases were being multiplied. What were we doing out here? Same bases were being multiplied. I was multiplying the same bases. But these two bases did not have the same power. Power was not same. Base was same. Power was different. But when I got the answer in the same base. What happened to the power? 7 I got as the power. How do I get 7? 3 plus 4 is 7. How do I get 7? 3 plus 4. What is this? They are the exponents or the powers in the question, and 7 is the exponent or the power in the answer. So what happened out here? When the same bases were multiplied, answer came in that base only. The powers were added. The powers were added. I'll give you one more example. Four raised to the power of 5 multiplied by 4 raised to the power of 2. What is the base being multiplied? 4. Are the bases same? Yes. Are the powers same? No. So let us see what happens. 4 raised to the power of 5 means I'm multiplying 4 how many times? 5 times. 1, 2, 3, 4, 5 times. And 4 is again multiplied 2 times. Right. Here what am I getting? Same base. Bases have not changed. All the bases are same. So I'll get my answer in exponential form. That is 4 only. How many times I have written 4? 1, 2, 3, 4, 5, 6, 7. 7 times I've written. So my answer is 4 raised to the power of 7. Now how did I get this 7 now? 5 plus 2, 7. Where did this 4 come from? The base of the question. How did I get the power? I got the power by adding. So this is called Law 1. This is Law 1 of exponents. First law of exponents. Now, what does the first law of exponents say? The first law says that when same bases are multiplied, the powers are added. What do? We add the powers. When do I add the powers? There are 3 points to remember. Number 1, same bases. Bases must be same. Operation must be multiplied. You have to multiply it. Then what do we do to the powers? We add the powers. When same bases are multiplied, the powers are added. This is law number 1. It is represented as any base, that is A, raised to any power that is m multiplied by the same base raised to another power, we get the answer in that base and the powers are added. A raised to the power of m multiplied by a raised to the power of n is the same as a raised to the power of m plus n. This is law number 1. Now we are going to do till here. You can write an example of law number 1 using any numbers, any base, any power. You can write an example. This law, you will write it in your homework book. Neatly in your homework book right now. Later on, you can do it in the classwork book. That's all for today. I'll see you tomorrow. Goodbye and have a nice time.